Hello everyone, welcome to the first online lab. Today we will go through lab number 3, the resistor color code system from the DC lab manual. We will learn how to read resistors using their colors and also how to measure these resistors using a digital multimeter. The things that we need for this lab are a digital multimeter and a resistor, your resistor kit. This will probably the same resistor kit that you would use if you have ordered the link that I provided in the lab material needed on your blackboard. These resistors come with label, but most of the time you don't have any labeling for the resistors. So if you have a resistor, for example, a 1K resistor or a resistor which is unlabeled, on the resistor itself you would see the coloring, different colorings of a resistor. So I would try to zoom in to show you a different coloring of this resistor. Let's see if we can. So for example, in this case it starts with brown, and then we have black, and we have red. According to the resistor's color chart, brown indicates number 1, black is 0, and red is 2. So the resistance for this resistor is going to be 0 times 10 in a power of 2, which is the color red. So it's going to be 10 times 100, which is 1000 ohms, or 1 kilo ohm, for example. Now, how to use the digital multimeter to measure the resistance? On the digital multimeter knob, you would see, if you use the same digital multimeter, I will recommend for the online students to use the other digital multimeter, which also has an oscilloscope, because you can do both AC and DC measurements using that, and you won't need a separate oscilloscope. So I would highly recommend to get the DMM, the digital multimeter that has the oscilloscope. But they'll both look the same when you want to measure the resistance. So on the digital multimeters, you would see the VAC sign, which is like a signal sign, and then you would have the DC sign. So this one is the 500, 200, 20, 2000 milli, and 200. These are for measuring DC voltage. And these two, 200 and 500, they are for measuring AC voltage. So this sign is for AC signal, and this sign over here is for DC signal. AC voltage and DC voltage. And on the right here, you would see, if we want to measure DC current, this is the current DC, you would put it on one of these knobs. And here generates a digital signal. These two signs are for testing a diode or testing if we have a short circuit. So for example, if I put it on this beep sign, and if I connect these two, I would see that I have a short circuit. So if I have another wire, for example, I have a wire here, and if I want to check and see if they are connected, if I put it this way, it will make a beep noise, so I would realize that I have made a short circuit. And if I put it on the next one, it will show me the resistance. So this is the resistance sign. I can measure from 200, 2000, 20K, 200K, 20 mega, and 200 up to 200 mega ohm resistance. And finally, again, we have the DC voltage. So for the resistance color code, you have to first determine the colors on the resistance. In theory, find it. If you have the last color is gold, it has like a 5% tolerance. If it's silver, it's 10%. So you have to measure it and measure the tolerance. Then you put this on the resistance side, the resistance, and let me zoom out a little bit. And if you connect these two now, you would see that now it shows, for example, this one, it shows 95, this one is a 95 ohm resistor, for example. So it's gonna be, let me double check this. I'm sorry, I have to connect it properly. By the way, when you're measuring the resistance, make sure it doesn't make any contact with your finger, because the human body also has some resistance. So you want to make sure that you can connect it like this. So for example, for different type of resistors, you can measure the resistance. This other resistance, this is like 450 ohms. We have a lot of different type of resistors. This is like a 33 kilo ohm resistor, and according to the table, you would just measure the resistance by putting this, so 33K, because this is 33K, it's obviously more than 2,000 ohms or 20 kilo ohms, so it's better put it on 200 kilo ohm, and then we can just connect it like this, and you can see here that we have, for example, this one is 32.2 kilo ohm of resistance, because we have like 5% of tolerance, so this is in the acceptable range. So if you have a bigger resistance, you need to change the multiplier over here, and you can easily measure the resistance. Another important thing is on some multimeters, the terminal, we have 3 terminals for the multimeter. One is the common terminal. You must put the black terminal always in the common terminal. And when you want to measure voltage, resistance, or any current in milliamp, you must use the middle one. And anything over 1 amp or over 1,000 milliamps, you should use this one. If you have a high current system and you use the middle one, it's going to damage the multimeter. So make sure that you use this properly. Some multimeters are different. Even for milliamp current measurements, you must use the other terminal or other port for the measurements. So this was about the multimeter itself. Another important thing is the breadboard that you're going to use a lot in this lab. So we're going to use a multimeter again to measure, for example, the 33 kilo ohm resistor. Keep in mind that in a multimeter, in a breadboard, on the side you would see like A, B, C, D, E, F, G, H, I, J. Keep in mind that A, B, C, D, and E, these 5 ports, I can say these are connected to each other. So A, B, C, D, E are connected, but they are not connected with the adjacent vertical, I could say, terminals or ports. So if I connect, I'm going to give you an example of how we can test it. So I'm going to connect a conductor or wire here and here, and I want to see if now these two are connected. I can put the multimeter again on the short circuit tester or the beep sign that you would see, and if I connect these two now, you would hear the beep. It means that now these two are connected. And if I put it on in another one of these holes, and if I repeat that, again, you would see that they are connected. Let me zoom in a little bit so you can see it better. So again, these two are connected. But if I put it in the adjacent or the next column, you would see that now they won't beat. So it means this column and the adjacent part are not connected, but each of these columns, these rows are connected to each other, but they are not connected to the adjacent ones. And this column over here is separated by this gap, and it's not connected to this one. So if I want to test this one as well, I can simply insert another conductor here in the second column, and if I connect these two, you can see that they are not connected to each other. So only these 5 holes are, I can say, connected to each other. And on the top and the bottom, you would see this red and blue line. These are for your power supply, or they call it the power bus or power terminals. These are connected horizontally. So this until the end, these are connected. So if I connect the positive here and here, you would see that these are connected. But the positive and the negative, these are not connected at all. So you can connect your power supply to the positive, and the positive to the positive, the negative to the negative, and then use jumper wires, which you would have, these are called the jumper wires, and then you can connect the negative to, for example, the ground to the ground using these type of jumper wires. So when you want to connect an element on a circuit, put one of the terminals on one side and the other one on the other side, so they won't be short-circuited. Now I can give the input to this side, and the output, I can take it from this side. And as you can see, if I connect these two, it's not going to make a beep. It means you don't have any short circuit or short circuit connections. And I can put it this way, and I can measure the resistance as well. So for example, this is a 1 kilo ohm resistor, and if I connect it, and I can show you here, it will show me exactly 1 kilo ohm resistor. Another way to put an element like a resistor, capacitor, transistor, anything on a breadboard is to put it this way. Again, these 5 are connected to each other, but these 2 columns are completely separate. So if I test it, you would see that they are not connected. And if I want to put some resistors in series, I can simply put it like this. And for example, this could be my input and this could be my output, and these 2 resistors are now in series. You can see that the terminals now, if I connect them like this, and I put it on the alarm set, you would see that these 2 resistors now, they are going to be connected to each other. So if I test them now, you can see that they are connected to each other. I'm going to zoom in a little bit so you would see actually how they are connected to each other. So because they are on, again, one column, they are connected to each other. And now I put these 2 resistors in series. If I want to put the resistors in parallel, I can take this out, and again, I can put them both terminals in the same column. So as you can see now, they are now connected to each other, and this is the other end connected to each other. So these are now in parallel. Now, in the lab we have a power supply which looks like this. If you can have but you probably don't have a power supply like this, and you don't need one for most of the labs. The other thing that you can do instead of the power supply, you can use like a battery or a motorcycle battery like this, a 12-volt battery, and you can use a potentiometer on that and adjust the voltage. Another thing that you can do is to buy these small power supplies on Amazon. They are like for $20, $30 each. It's going to be very helpful if you're an electrical student. Then you're going to use it in the LIC and the measurements lab. And you can also use battery trays, like put AA batteries in series. If you put like, I don't know, 4 of them in series, you're going to make a 6-volt system. Or if you put 6 of them in series, you're going to build a 9-volt system. Or if you put 2 of them in series, you're going to build a 3-volt system. So you can put like different batteries, you can put them in series and generate more voltage. So different ways to do that. So for the first example, we want to measure for lab number 4, we want to measure the current passing through a resistor and its voltage. So what we're going to do here, I'm going to connect one end to the negative and the other end to the positive. I can do it this way, or another way that I can do it, I can give the positive negative to these terminals and connect them with a jumper wire. Whatever works for you better, you can do it that way. And for this particular example, if I want to measure the voltage, I have to put it on DC voltage. And then this is going to be in the voltage. And I would simply put this in parallel with the system. And now you can see that the voltage here is 6.8, 6.9 volts, something like that. So you can measure the voltage like this. And for measuring the current, you have to take out, so the voltmeter goes in parallel with the resistor. To measure the current, so if I want to measure the voltage, again, you just put it in parallel. If I want to measure the current, you take this out, put it in another terminal, which is disconnected now. Then we will put this on DC current. 20 milli would be good because it's around 20 milli. And then we would put this in series. So putting it in series, you're able to measure the current. And here you can see that our current is around like 30, 40 milliamps. So for the current meter, you have to put it in series. For the voltage meter, you need to put it in parallel. Another thing that I want to mention, so resistors, you can read them based on the colors. There is a color chart online. You can look at that and you can easily read the colors and be able to calculate the resistance. You can also measure the resistance using a multimeter. For the capacitors, it's a little different from that. For example, this capacitor, there is a number on it. It's 103. So 103, it means it's 10 times 10 in the power of 3 picofarad. Picofarad is 10 in the power of negative 12 farads. So this is going to be 10,000 picofarad or 10 nanofarad. Another example for this is we have a bunch of these. Is going to be, for example, this one is 221. So 221 is going to be 22 times 10 in the power of 1. The third digit is the power of 10. So it's going to be 22 times 10 in the power of 1, or 220 picofarad, or 0.22 nanofarad. So this is another type of capacitor. Another type of capacitor that we're going to use in the course are these electrolytic capacitors, they call it. These type of capacitors and the resistors don't have any polarity, so it doesn't matter which way you put it in the circuit, but this one has a polarity, and if you put it in the wrong way, it's going to just you're going to destroy it, and it's going to burn, it's going to blow up. So you have to be careful with these type of capacitors. These type of capacitors have a negative sign on them. This negative sign must be this terminal, actually, which is a shorter, by the way, it's a shorter pin, but it's not always the case. Some capacitors have the same size pin, but usually the shorter pin, which has the negative sign on it, this is the this must be connected to the lower voltage or the ground or the negative voltage. So if you have a battery, this should be connected to the negative terminal of the battery, or the grounding of your system. These type of capacitors are very easy to read. There are a bunch of numbers on them, if you can see. So for example, this one says it's 330 microfarad, 25 volts. Let me bring another one. Again, this one, the shorter pin is the negative, and you can see the negative sign here. And this one is a 0.47, I don't know if you can read it, but the second line, 0.47 microfarad, 50 volts. So 50 volts is the maximum voltage that this could endure, and the capacitance is 47 microfarad, 0.47 microfarad. This is a 680 microfarad, again, the negative sign as well. So this is it for today. I hope you learned from the class. Please reach out to me if you have any questions, and I will post videos for the next labs next week's. Another thing that I want to mention before I finish this class is for each lab you need to do a theory part and answer the questions with the lab as well. So if you have a lab report, you fill out all the tables. You have a theory part, for example, if you're measuring the resistance, you have a theory part to measure it using the colors, using the color chart. And then you have to measure the resistance using the multimeter. And you put them in the table and you compare them. And that's going to be your report. You just fill out the lab, you print it, you fill it out, and you scan it, you turn in the PDF file for that. And I haven't posted a due date for your labs yet, but it's going to be 10 days after each lab. For the online students, the first due date for the first lab is going to be next Monday, which is going to be lab number 3, which is the resistance color map, and also the series resistor measuring the current and the voltage, which is, I think, number 4. You have until Monday night to turn in your lab reports. If you have any questions or if you need an extension, just please let me know, and I would help you out with the labs. And thank you so much. See you in next week.